All right, let's go ahead and get started. So, welcome to the final review session that I'll have with you guys. I'll still see you tomorrow for the quiz discussion, as well as Wednesday for office hours. Your final exam is this Thursday from 3:30 to 5:30 p.m. It is in person and it will be hosted in JFB 101. So JFB is the physics building. Um, Here you can kind of see this is where President's Circle is. This is what the big building is. If you're not typically on campus, parking wise, this is a U law. I don't know if they made it a pay per hour, but otherwise you can park here after 3 with the U permit, as well as the second and third floor of the Northwest Garage. And then you should be able to park up here in the Union if you need to, or even here on President Circle, you can park, I believe it's $3 per hour, so just pay for 2 hours and you should be okay. This is what the building will look like. This is kind of the long part of the building. This road here is 100 South. Um, and you'll want to enter through either of these doors here. I don't remember if it's on the left or right side, but it is in Lecture Hall JFB 101. And yeah, be sure to have your cheat sheet ready. You're allowed to bring 1 page of handmade notes. Just make them yourself, front and back of your typical 8.5 by 11-inch sheet. You'll get 1 point extra credit for attaching your notes at the end of the exam. And some things I recommend for your cheat sheet is steps on how to do a specific type of problem, especially on materials after exam 2. Be sure to have all the key terms and definitions. So look through all your quizzes, see what kind of words pop up really often, or if they ask you things like, um, I don't know if they'll ask you the convertible or not with your inverse functions, but make sure you know all of the different key terms. Put examples of difficult problems. So whatever you personally struggle in, take some time to reflect and see what you can improve on with those, and then be sure you know how to do them, and then write them as an example if you'd like. And yeah, be sure to review your past quizzes and exams. Everything is posted on Gradescope. And then the solutions are fully worked out on our template page. They should be all the way updated until quiz 13. That's also a really great way to study. So remember that there is a final exam on, or sorry, there is an emphasis on the final exam of material after week 10, which will be about 40% of the exam. So the last things we've been doing the past 3 weeks. The questions will be similar in type to the quiz and past exams. The final is 7 pages long and it is written to take 90 minutes, but you are given 2 hours and 10 minutes. So you can go over time, but there is a 1 point penalty for every 5 minutes you go over. Use that time if you need it, if you think it's beneficial. 1 point penalty is a better option than getting a 0 on that question that you haven't answered. The expectations for today, be sure to have some scratch paper ready and to solve. Try right now to see if you can use that annotate button. It's that little pencil icon. Typically, it's in the bottom left corner of my screen. Uh, so I've got mine. If anyone else wants to try theirs right now, feel free. Also, please use reactions. I'll ask you if you feel like a thumbs up or thumbs down on the topic, as well as type in chat if you don't feel like using your microphone. Otherwise, be sure to use your microphone. I can hear you guys. So, yeah. Is anyone able to annotate? Great. So and if you're unable to annotate, feel free to type it in the chat and then I can just write it as it comes up. All right, so today's review will focus on material after exam 2, a little bit about it before, but not too much. And then we'll just be doing practice problems the entire time. So before we get completely into that, I just wanted to clarify kind of functions. I know a lot of people get confused on the notation, and it is confusing for a good amount of time. It's confusing until it clicks. So I'm going to just keep repeating this over and over, and hopefully it'll click at some point. So this part here in teal represents our function of x. Right? This is literally saying the function of x. So then that is like our output, right? So we plug something in for x, where like x is the input, right? And then that plugged into this blue part here, the algebraic expression that describes our output gives us the output. So we can do things like change our input, which will subsequently change the algebraic expression. And we've been doing quite a bit of this, so hopefully it makes sense. Like with this example, if we wanted to do an h of x is equal to 3x minus x is our h of x, right? So where x is our input, h of x is our output, 3x minus x is the function that describes our output. Would we be able to plug in this here? How would we do that? What is my h of x minus 1? And I can see the chat, so whatever the first step is. We want every single input to go from x to x minus 1. So what would I do?
You just input h of x minus 1 into each x position. So it'd be 3 times x minus 1 and then minus parentheses x minus 1.
All right, and then what do I do next?
Distribute.
Okay, so then what do I get?
You get 2x minus 2, I think. Yes.
Yes, yeah. So we have 3x minus 3, and then we have minus x minus or plus 1, right? So then we can combine these two terms, we'll get the 2x, and then we'll combine these two terms, and then we'll get negative 2. All right, great job. Okay. How about this one? What if I wanted h of 1/2? It's the same process, right? So whatever we input before we had that x, we now have replaced it with the 1/2.
Yes. Sorry, I was doing it. I didn't answer.
Oh, no worries. So we get something along the lines of this, where every single x has been replaced with 1/2.
Yes.
Then we get 3/2 minus 1/2, which is equal to,
Oh, would you not times 3 by 1/2?
yeah. So this is what I did right here between this step here.
Oh, right. Okay. Sorry.
No worries. Because we just have 3 over 1 times 1 over 2. So we can multiply across and get 3 over 2.
Okay. Yep.
Yep. So then what do we get here? Is h of 1/2 equal to?
It would be 1.
Yep. Do we all feel all right about this?
Yeah, I feel pretty good about it.
Um,
I just asked you like that timesing by half because I put 1.5. I didn't put 3 halves.
yeah.
So that's
And they're the same thing. So
yeah.
cool.
I was just wasn't thinking.
All good. Okay. Up next, do we remember inverse functions?
Yes.
Okay, so I have this function f of x is equal to x cubed minus 1, and I want to find the inverse function of a when a is equal to 7. With people's reaction, give me a thumbs up or a thumbs down on how you feel about this question. Okay, we got one thumbs up, two thumbs up. Okay. So then what would be the first step in this one? How do we find the inverse function of negative of x? How do we find this?
First, we're gonna plug in a, so it's gonna be inverse of f 7, right?
Yeah, we can do that.
Okay. Or maybe I'm not feeling super confident in this. Maybe we can just review it.
Yeah, so you can do it either way, but typically, I guess there's a few different ways to do this.
How would you typically do it?
Um, so you can, let's see. Sorry, ignore this part. We don't want to deal with that. I pulled this one off of somewhere. Um, Typically this isn't in the notation here. So do you want to walk us through this one, or do we want to? Okay, let's try to find the inverse of f of x first, and then we can plug in a. How about that?
Okay.
So then remember, when we have this, we want to inverse functions, we just flip our x and our y, right?
Yes.
So I can just put this as like a y is equal to x cubed minus 1. So then in order to get the inverse, I'd swap their places and then resolve for y. Okay. So then now what can we do?
Bring one to the x side,
Okay.
and then you could cube root it each side.
Yep. And then what do we get?
Y equals cube root x plus 1.
Yes, cube root x plus 1. So this is, let's only take the positive. There is two equations here, but let's just take the positive, right?
So
So,
when you're not sure of the, I always get confused with like the positive or negative thing. Is it just when, um, like how do I know when to put that?
so whenever you have any type of square root and you take it out of it, you need a positive
Okay,
sign. Yeah.
it's
And
just
we
to
don't
like
know what
not sure.
y is exactly, so we have to make sure we put a plus or minus. Either way, let's only take the positive in this case. So we can replace this y back with f of negative 1 of x. And then we get this. Right. Okay. I guess purple isn't the best idea. So then now what can we do to find f negative 1 of a?
Now we plug in 7.
Yeah. So we plug in 7 for our x's. Okay.
That should equal 2.
Yep. Okay. How do you feel about this?
Better now.
Okay, great. I'll go ahead and move on. Um, so this one is pulled off of the exam review. This is more of a story problem. This is a little bit more from the beginning of the class, but I'll go ahead and read it off. So we're trying to measure steepness. We start college with $1,000 in the bank account, and then this table shows the account as time passes. Is our time or the money the input?
The time.
Yep. So then time is our input, and then money is our output. What about our independent and dependent variable?
Time is independent and money is dependent.
Mhm. And I kind of wrote this so that way you could kind of remember that the input and the independent variable are usually the same thing. And then your output and your dependent variable are like usually the same thing. And it's only not usual in higher levels. So that's like a generalization that you can make for this class for sure.
Okay.
All right. So then if I wanted to find an equation, what could I do?
Find
So,
the slope.
okay. So which one do you want to find between first?
We can just do box 2 and 3, I guess. I don't know.
Yeah, for sure. So from month 5 and 7, how would we do that?
So it'd be 8,250 minus, yeah, it'd be that y1 minus y2 and then x2 minus x1. Or, sorry.
Yep, they're the same thing. Yep,
Okay.
you can change the subscripts either way. Yeah.
Okay.
So we'll make this one our, so you said 8250 minus
8,750.
8750 over
7 minus 5.
7 minus 5. Okay. So then on top we get 500. And then on the bottom we get 2, which gives us 250. And then this level of math, are you able to solve it relatively quickly? Do you feel like you would need a calculator?
No, definitely not.
Okay, cool. Hopefully this is all right. So then we have our m is equal to 250. So then how would we make a function out of this?
Next, we put it into y equals mx plus b, and
Mhm.
then we could use 10,000 as our y-intercept.
All right. All right. So that's exactly what I would do. But I did realize that in this problem, the month jumps from 5. So it's not necessarily a linear equation at every point, if that kind of makes sense. So like it, or wait, hold on a second. It might actually be, I think I did my mental math. 10,000 minus 8 times 0. Okay, it is still 10. Cool. So then what does this kind of look like? If I had this graph here. That's 10,000 and this is,
Be steadily decreasing since it's linear.
yeah,
Just be a straight line.
something like that. Cool.
Yeah, about.
That's not really to scale. No worries. Okay. All right. This one was from one of our quizzes, and I believe a lot of people had struggles. Would we be able to, what would be the first step we want to do to make this x squared minus 12x plus a perfect square?
Half 12.
Okay.
We'll use half 12 and then square the half.
So then we get -6 squared, which is equal to,
36.
all right. So then we have x squared minus 12x 36 as our equation. Cool. So then what about this one? Part B of this problem. We have x squared plus ax plus 4. What can we find for a? That'll give us a perfect square.
Would it be a squared x squared over 2 to make it a perfect square? I'm just guessing here.
Sorry, what did you say? Let me write it down.
A squared
A squared.
x squared divided by 2. Well, I
So,
guess if it was squared, it'd be divided by 4, right? Sorry, I'm just guessing here. I don't know.
no, you're good. So, um, before we did like x squared minus 12 plus a is equal to like a x minus 6 squared, right?
Right.
Where a is equal to 36. And to do this, we took the 1/2 of that and divided by 2. So if we wanted to solve for this and we have an a, we plugged in a equals, we can plug in a equals 4 here. But then how do we plug in an x in this?
Oh man, I have no idea. Sorry, I'm like
So,
just hitting what
mm,
I don't remember.
yeah. And this is why reviews are pretty good. So that way we can kind of remember. Does anyone else have any ideas or remember how to do this one?
Wait, wouldn't it just be 36x? Like x squared plus 36x plus 4? If a equals 36? Is that what we're doing? Or
So we're solving for the second a, right? To make a perfect square where we want an x plus or minus something. Or sorry,
so they're A and B aren't related then?
not necessarily. They're similar but not related.
Okay, that's I was getting confused with that. I see.
Nice. Do we remember how to do this? Anyone else have any other ideas?
So if it was a perfect square, A would equal 4.
And how did you do that one?
I just divided or square rooted 4.
Right. So to get this perfect square, we took our c term in this case and we put like, did you do that?
Yes.
So then,
Oh, sorry. Then it equals 2. Um, but then if we had a perfect square, 2 squared would be 4. So it'd be 2x or 4x. If we
so
were to
like,
take A, and if A equaled 4, and then we halved it, so 2, and then we squared it, we'd get 4. So just,
okay, cool. So you worked backwards. You worked from
yeah,
this function here.
yes,
That would be, okay, cool. I remember when we have our square roots, we have a negative version of it too, right? So we
right.
have an x minus 2 function, which means a is equal to 4 and negative 4.
Oh, okay.
Yeah, yeah, and there was a hint, so there will be two different a's.
I didn't even read that to be honest, so
All right, yeah. So hopefully this is something that was good to review. I don't know if it'll be on your exam. You haven't seen it and we don't get to see it, but I will be there on the day of. So I'll see you guys there at least. Okay. Go ahead and move on. Um, Factor by grouping. Do we remember how to do this?
briefly,
Okay. It might ask you to factor by grouping. It'll probably if I was to make a test for this exam, I'd probably do one example of all the different types of factors that you guys have covered, or like solving for x's, right? So with the factor by grouping, we want to group them in a way that we can take out the same common term from both of them. So if we want to, we can do one of these. Let's see. Let's do this one. This factor by grouping is really useful when we have uh, an x or an n term to the third power, right? Because then we're able to factor out an n. Does anyone remember the first step in factor by grouping?
Split the two.
Okay. How do you
Split
want to
the two
split it?
groups. What was that? Sorry.
How do you want to split it?
Uh, 12n cubed plus 4n squared in a parentheses, and then plus parentheses 3n plus 1.
And then what can we do to simplify the first term? This first term here. We can take out common factors from both terms, right?
Yes.
Okay. What can we take out?
We can do 4n2 for,
Yep.
yeah,
And then we'll get
3n plus 1.
okay.
It would
So
be
then
3n plus 1 in parentheses, and then another parentheses, it'd be 4n plus 1.
all right, great job. Okay. So this we went from here to here, and then we do, if anyone's confused on where this one came from, it's because we have a one right here. Right? There's always a one in front of the parentheses because we're distributing that, but we don't typically write it. So whenever we do this, we can combine the front term and this front term here, and we keep this sign here. So great job. Hopefully we feel good about this. If not, there's this entire um, worksheet linked, and if you scroll down, it has the answers, so you can check it. If you don't get a good factor grouping at first, then you can always try again. So you can group two other ones together to try to get it to factor. And that's one that you can put on your cheat sheet if you would like. And then let's go ahead and move to square roots and simplifying exponents with combined. Do we feel comfortable with this?
Yeah, I
This
feel pretty comfortable.
okay. Do you want to walk me through it at all?
Yes. Is it okay if I write it out first?
Of course. Yeah. Yeah. And when you do that, we'll have the -6 root, and then we can divide 12 into 2 times 2 times 3 times 3. We'll have C 7. We have K to the 13th. We have X to the 14th. So with even exponents, I have the even exponent of K to the 14th and an even exponent of X to the 14th. With these ones, I can simply divide it by the 2, right? So I can just divide these by 2 and take them out. So that's a little bit of a shortcut if you don't, if it's hard to write out the whole thing. Say this was a cubic root here instead of a second, then I could divide this by 3, and then I would be able to take out the number and then leave the remainder under the exponent. Anyways, let's go back to the 2's. So I can take out 2 and a 3. because I have two of them. So I'll take that outside. And then I'll get a negative 6 times 2 times 3
Where did you get the
squared.
3 times 3?
So 12 is broken out into, oh, sorry, I have too many threes. You're right.
All right, I was just a little confused.
Sorry, that was my bad. We don't have another 3 here. We'll have a 3 on the inside though. So then we'll have negative 6 times 2, and then we'll have a 3 on the inside. So into this one. And then we took out k divided by the exponent divided by 2. So we get k to the 7th. Then we can do the same thing with the x to get that to a 7th.
Could we
And
also take z to the 7th and split it up to z6 times z and then get z to the 3rd?
yep,
Could we do that as well?
of course. So we can do that times z to the first. So then we'll get negative 6 times 2, which we can just write as negative 12, right? K to the 7th, x to the 7th, and then we'll have our z6 divided by 2, which is just z to the 3rd, and get 3 times. Okay. Any question? Just a quick review on logarithms. Put this equation here on your cheat sheet or whatever version makes sense to you. Remember that our x is our exponent, our a is the number that we're solving for, and then b is our base. So these are mostly color coded. This should be blue, or sorry, this should be green to match this green here. But these are all the same numbers that you can just pick out and put into the other version of the equation. So when you're solving for this number, it's easier to do it in this form, this first form. And then when you're solving for x, it's easier to do in the second form. Okay, let's go ahead and do this one. How do we find x? We want to get x as close to a lone as possible. So I want to get the furthest thing away from x, away from x. So that means I'm going to divide both sides by -5 first. I'll get 2 to the x is equal to 4. And then now what can I do to try to solve for x?
Square root 4.
Can we square root 4? If we square root both sides,
Oh, um,
yeah. So in this case, we'd want to utilize the conversion between these two.
right.
Okay. So then what is my base?
It'd be 2.
Okay. So log base 2. And then what's my argument? My number that I'm looking
4.
for? 4. Okay. It's equal to x.
And from there, x equals 2.
Yep. Because we have 2 to the 2 is equal to 4. So we know that our x is equal to 2. And you can do that either way, whatever way makes sense to your brain. If you're able to go from here or directly into 2, then that works too. Right. So this is something that I went over more in the first exam because that one was more like a lecture based. But just keep in mind that you may be asked to predict behaviors of different types of common functions that you've encountered. And you should probably know what different things mean when they're added. So when you have like an A stretching term or a like C adding term, right? So I went over more, but just know the basic shapes. So your quadratic formulas have that parabolic shape. Your exponential functions have that slow growth and then a shoot up towards infinity. Your y equals x is just that line where every y value equals every x value. And then you also have your square root function that starts at a 0 point, or it starts at 0, 0. It's never negative in this direction, and then goes on towards infinity. We also have our log base 2 of x, which is the inverse of x, or 2 to the x. And that's symmetrical along the line of y equals x. So these are all of them put on the same thing, but just try to get familiar with it. You'll see these functions all the time, especially further into math. So it's a good to get a really good basis of them. So here I've graphed the square root of x plus 3. What is the domain and range of this function in interval form?
So it'd be 0 for domain, it'd be in parentheses 0 comma infinity for the domain.
And then do we have closed or open parentheses on these?
So we have a closed on the 0 and open on the infinity.
Okay, what about the range?
Uh, so it's 3 to infinity,
Okay,
and it's closed parentheses on 3 and open on infinity.
all right. Does this make sense to everyone? I know some people have questions on interval notation, and that just means this here. Um, remember, we only have a closed parentheses when it's touching that point exactly. So we have a point exactly here at 0, 3. So we have exactly that bracket because we're up to and including. With infinity signs, we always have the parentheses, so that curved bracket, and that's because we can't technically include infinity. We can't enclose it into anything. So that's just math notation you'll see very commonly. If we wanted it in the other notation, right, we could say that x is greater than 0, and then y is greater than or equal to 3. That should be closed. Okay. All right. So inequalities, this is the very beginning. Just wanted to mention something really quickly. When you have negatives, adding and subtracting, as always, must be done to the same on both sides. Multiplying or dividing by a positive number, the inequality sign remains the same. But if it's by a negative number, then you flip the inequality sign. So for example, let's just do this one really quickly. So we want to solve for x. So we'll divide both sides by -5. And because we are doing a division or multiplication by a negative number, we have to flip the inequality sign. So we'll get x is greater than or than -5/7. Okay, just remember, put that on your cheat sheet. Don't forget it in the exam. You might have some inequality stuff. And this is a really sad thing to lose points on, is forgetting to flip that. Okay. Hopefully you've seen this table before. I've shown it at multiple review sessions. This is a really good kind of combination of all of your exponents that you'll see a lot. So your exponent rules, as well as a little bit on square roots. So remember your a and your n are two different exponents. Your base is your a, at least in these first three. Make sure you know how to use this and read this, where, and make sure, let's see, this one's a pretty important one when graphing, where anything to the 0th power is just equal to 1. So that's a really good way to see, to differentiate your exponential functions, because you'll know at every single, regardless of what they are, um, they'll have an intercept there, unless it's like shifted up or down, but they'll have an intercept 1, 0, right? Okay. Anyways, be sure to know this here. You guys have done square roots. And if you want to change it from a square root into a fractional exponent, then you can take this inside number over the outside number, and then you get that there. Okay. Linear systems of equations. We did these a while ago. You'll probably have one on the exam. Just remember that you can have infinitely many solutions cases and no solutions cases. You can go back to the exam reviews for exam 1 if you would like, and then they'll give you some more practice problems we did together. These ones here have the same slope, but they have a different intercept. So they will have no solution because they'll never intersect. Okay, so we have 15 minutes. So we can do we want to do a system of equations, exponential, logarithmic? Which one do we want to work through? If you guys want to say it in the chat or in a mic, we can do a little vote.
Let's start with system of equations because I'm a little rusty on that.
Yeah, yeah. Well, if we have no other votes, maybe we can get through them all. Yes. So number 22 is a system of equations. This is just the exam that we posted. So Gabby is selecting a moving company. Friendly Movers stresses a base fee of $200 and $30 each hour for two-person crew. Here to Help Movers charges a base fee of $20 and $50 per hour. So then let's focus on the first moving company. Let's make a function that describes their rate. So
200 plus 30x.
yep. Okay. And then what about h of x for the help movers?
20 plus 50x.
Okay. Okay. So now we wanted a 5-hour job. How could we find which one's less expensive?
Just plug in 5 hours to x on each equation.
Okay. Okay, so we have f of 5 is equal to 30 times 5 plus 200. What does h of 5 equal to?
50 times 5 plus 20.
Okay, and then let's go ahead and see, that's 150, please.
Yes, 150.
Plus 200 is equal to 350. And then we have 50 times 5, which is 250. Is that right? Let's see,
Yes.
50. Yeah, okay. So we get 270. So then we know that the here to help movers is cheaper, right?
Yes.
Okay. So then how about on D? How do we figure out what hours?
So we do 200 plus 30x equals 20 plus 50x. And then subtracting in from each side. 1 sec, sorry.
Okay. Which one do you want to subtract? The 20?
Yeah, let's do 200 minus 20.
Okay, so we get 180 plus 30x is equal to 50x.
Then we subtract 50 from, or 30 from 50.
Okay, so we get 180 is equal to 20x. Divide both sides by 20. What do we
And that should give us 9.
All right, so then now we know that 9 hours is the point where we'd want to switch to the other company. Cool. And I really like this problem because it's pretty real world based. Okay. So what's the next one that we would like to do? I did a parabolic one in the last exam or in the last exam review, so I don't think I'll be doing that one. But between the exponential and the logarithmic, they're pretty similar. So I guess we can do 26 first. Just stay in the close. Okay. So this is dealing with constant percent change and modeling of this. So 26 asks you the directions on the bottle of sunscreen instruct you to apply it every 2 to 4 hours because its effectiveness diminishes over time. The effectiveness of sunscreen can be modeled with exponential function. So suppose that SPF of a sunscreen is 50 at time 0, and every hour the effectiveness drops by 30% of its value it was its previous hour. What is the SPF after 1 hour? It's 50 times 1 minus 0.3, right? So let's see, 50 times, and then this is equal to 0.7. So we can multiply 50 by 0.7, and then we'll get 35. And then now we take this 35, we put 35 into our base equation, and then we multiply it by 0.7, and then we get 24.5. Okay, so how do we write a function for what we've done here? Our S of x, or SPF per hours.
Wouldn't it just be S of x equals 50 times 0.7 to the power of t? Or to the
Yep,
power 7, or just power of x?
x, yeah, same thing, yeah, cool. Okay, so we got this here. So then C, what would the SPF value be after 8 hours? S of 8 is equal to 50 times 0.7 to the 8. Get here. To the 8th
Sorry,
power.
just looks like I gotta do it.
No worries. I am also trying to find my calculator. Okay, 0.7 to the 8th power times 50. And then we
That'd give
get
us 2.89 or 2.88.
2.8. Cool. All right, so then suppose that the SPF is 40 and the effectiveness still drops by 30%. So what's G of X equal to?
G of x equals 40 times 0.7 to the power of x.
Great job. Okay. How about H of X? We start with an SPF of 60 and the SPF effectiveness drops by 20% each hour.
So h of x equals 60 times 0.8 to the raised to the x power.
Great job. How do we feel about this?
Pretty good. At first, when I was looking at it, I was a little intimidated, but I just needed a refresher.
All right. Okay. And then I believe the next one was problem 42. So we can do that as well. Let's clear all of this. Okay. All right. So We have an antiviral medication, and the amount that the body decays is 24% per hour. One dose of the medication contains 200 milligrams of active medication. Suppose the patient takes a dose, write a model for how many milligrams of medicine remain in the body after T hours. So what would be model D of T?
So I just put D of T equals 200 times 0.76 raised to the T power.
This one's pretty similar to the one before. All right. So
When
then,
we're dealing real quick with a question, sorry. When we're dealing with decay, we're doing the one minus the percentage, right? So it'd be like 1 minus 0.24, and that gives us our decay rate.
yeah.
Okay. Sorry to interrupt. Sorry.
No, you're good. And remember, a keyword is like every hour. That's kind of one that we can um, remember that we want to do it by like something to the T power, right? Because we want to be able to replace our T with the amount of hours that it decays. Okay. And then remember, we can do the same thing with like an increasing function, right? So if we had an increase instead of a decay, so if the amount increased by 24% every hour, then instead of having a 0.76, we would have like a 1.24 because we do something like to the
Oh,
T.
that makes sense because I was confused about that beforehand. Um, but you just add it. Okay, yeah, that makes sense why we have the one.
The next part, for the treatment, a patient should maintain at least 500 milligrams of medication in the body until the treatment is complete. Use the model to determine how much time the first dose should the second dose be given. And we want to use logarithm. So how would we, let's see, what's something that we want to make sure? We want to make sure that there's at least 50 milligrams. So where can we kind of put that into our equation?
Would we put 50 milligrams into our argument?
Yeah, but where would we put it? We would, what can we replace with 50 milligrams of our DFT?
I'm not sure.
Our DFT, right? So we want to make sure that's at least 50.
Oh,
So we want
right.
to make sure that this is, I guess, we'll just be greater than. So it's like a 200 times our 0.76 to the T. But in this case, we'll just put equals to. Um, and then we want to solve for T. So let's just get, okay, we don't need the equal sign or the greater than sign. How would we turn this into a way we can solve for the T?
Can we divide both sides by 200 to get rid of that 200?
Okay. So then we get 50 divided by 200. And then we get 1/4 equal to 0.76 to the T. So now how do we solve for T?
Man, I can't remember.
So let's use our log definitions, right? Our A, or I guess our B of X is equal to A. Our X is equal
Oh,
to our log of B of A.
so we just put log uh 1/4, and then our argument would be t equals 0.76. Is that what it'd be?
Yep. So we get T is equal to, yeah, what you said earlier. Sorry. I've had a really long day.
It's okay.
Yes, that 0.76 and then is our log. So log base that. Okay. And our A is just 50. Okay. This wouldn't be something that we would need to solve for on the test, but it is something good that we can model. All right. That's about time. Were there any other questions that we had in regards to the exam on Thursday?
No, not any that I have.
All right. Let me go ahead and stop recording.